Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay. So, last session we tried to implement the parse function here, which then would also give us the end type. The end type. Yeah. I do wonder if there's any relation between, let me see. So if we look at, I think hex 24, was it 24? Fun 24. So it's here 1 1. What is this? What is this bullshit? I don't understand. What is this behavior? Why is this so retarded? Working on it. How hard can it be to load and display a file? I don't understand. Like what is this? It's unbelievable. It's absolutely unbelievable how retarded this is. Crazy. How do I open this file? End list. Now that opens. Jesus. So, which bit is it? It's bit 3. 1, 2, 3. What value is this? 4. I don't know if that means anything. Maybe not. 4. There's no 4 here. Well, defined. I don't know. Okay, where are we? Here. Parse function. Okay, so let's see where it hits. Okay, so we got this abomination here. E. E, what was E? And sect. Okay, let me let's do int a equals 0. Let's gather some. Let's look at some hits. What do we got in there? So we got section B, E, section 14. Global N, global N. Yeah. E, B, B, B. How about we put std map, std string. Let's put a std set uint 8t, say n types, and std set what's it? Uint 8t sections. Okay, let me do a g n types dot emplace symbol dot raw type and g sections number of sections. Okay, parse function. Let's put a breakpoint here. Okay, types is only one, just E. Sections, just 2. B and 14. Huh. Okay. E. Strange that this says 3-bit set. Why? Maybe there's some reason to it. I don't know. Also A is indirect. Because there are different combinations, I see. So this all one set, then it's that, 2 there, indirect, 1, 1, okay. Mask for the type bits, and type. I think the correct way to write this here is nType equals nsect. Yeah. Yeah, so we do expect it to be in a section. And pxt. What was that again? That was the EH, right? Yeah. We should probably check. We should probably check that this really just includes. Let me comment this out. And then we say assert. Assert. So this is 0 or symbol name dot find, let's say string std string name dot find dot eh is not std string and Parse. So this should never hit this assert. Let's see if that's true. Maybe you should check section instead. I would expect that EH refers to some specific section. Section 5. Okay, so here EV name overridable. And we already, the first one already hits assert. Why? 1E? Oh, it is a 1E. And it's not an EH. Okay. Okay. Oh boy. Yeah. Okay. Well, then we remove this assert. Okay, good. Good, we talked about that. Then let me... Let's see what kind of sections we get now. Types 2, E and 1E, okay. And sections, oh wow, that's a lot now. 1, 5, 7, 8, B, D, 14, 17, okay. Interesting. Interesting. Okay, well, I guess we can work with that. Yeah. Yeah, yeah. Sections. Now what we can also test is what happens if we remove this entire check. What would then happen? Nine. Okay, so there's something in section 0. 1 and 12. Well, the question is, do we care about symbols that don't have a section? I don't know. Probably not. I don't know. Maybe we can put an assert here. Condition uint at section equals that, and then we say assert condition section equals 0. What does that say? Okay, section 0 symbol is .eh. Okay, we are not interested in this one. It's type 12 section 0. There's another one. Yeah, okay, so type 12, type 1, 2, 1, 2, type 1, 2. Okay, let's say a type symbol. Let's do n type condition, and n type is not 0x12. Okay, well, it seems to take a while. That breakpoint is expensive. Maybe we should have done a check. Yeah, it seems to be very slow. If section is 0 and n type is not 0x12. There we go. Let's put a normal breakpoint here. The problem with the conditional breakpoint, software breakpoint, it's very slow. That's a problem. I don't know why it has to be so slow. This will be very fast. This will hit in no time, but the conditional breakpoint somehow very, very slow. There we go. Okay, what do we have? Okay. I see. Yeah. Okay, we are certainly not interested in this one here. Description 801. I gotta watch some what is this here? Let me put this condition down here. Put a breakpoint on there. Actually, we have to move it here. Okay, section symbol. Yeah, this one we don't need. exchange and add. Exchange and add. Yeah, we don't care about this. I don't think so, no. SCD string compare. Yeah, we don't care. It's nothing that we implement. Okay, so these are functions that are being imported from somewhere, right? From the template library, SCD template. Yeah, okay, that's fair. Okay, good. Then I think what we can do is we can leave this check, but we remove this check here. And the next step is we have to filter by sections. So we have a section here, and then const section. And we need to question is, are there, oh Jesus, are there any enums for sections or only names? I think we need to also pass a binary. Pass function binary. What do we? Yeah. Binary. Okay, then binary dot sections. Sections. Why is this returning an iterator? Is there no way to like index these things? I mean, if there's an index here, I would expect that we can use the index somewhere. No? Returns an iterator. Sections. Sections cache. What's that? It's a vector. Okay, then how about sections? Iterator plus section. Does this work? Leave it const section. No. IT section. No. What is it returning? Oh boy. Where is this defined? A. Binary. Oh my gosh. Class by what? Leave. Class binary. It's inside the class? What the fuck is that? Why is this inside a binary? Why is this disappearing? This is retarded. Okay, that seems to work. No? Section IT section IT cons section. No? No? Leave MachO binary. Oh my gosh. So complicated these types. Okay, IT okay, so IT section IT section name. Let's just put a breakpoint here and look inside, see what it looks like. Okay, IT section, text. Text, binary sections. Sections. Where's the section name? Text. Text. Pick symbol stop. Symbol stop. C string. Okay, how about we collect all the different names now. Let's hold on. Yeah, we press F5. Then we go here and sections. We put that. Oh my gosh. Put that here. We copy it. We do notepad. And we do binary. Here, binary. Sections. And let's put binary down here. And then, okay, so we are interested in number 1. Pick symbol stop. I don't know what that means. Well, we will figure out. 05 const call 07 frame. Huh. I don't think we are interested in that one. And 08 constructor. Huh. Constructor. 0B. 0B. Zero B. How about... No, let's collect that first. I think that's fine. 0B. Actually, how about we collect all literal 8? How about we collect all names? Okay, let's write down all the names we see here. So we have zero is text. Actually, we probably have it somewhere already here, right? In this file here at the top somewhere. All the section names. Maybe. Oh man. Here. Yeah. 22. But this is for the other one. I think we are interested in the second one. Here, this one. There we go. EH frame, that's pretty big. Huh. It's really big. Okay, how about we take this and we We create an enum section IDs. And then we delete all this. Then we remove this, and then we delete all this. And we add commas. And then let's just call it section. Okay. Jesus Christ. Okay, and then what we do is we build a, let's call this section size. Section size. Yeah, and we can probably make it a uint very small. And then we can say std. What do we do? Std unordered map. uint8t section. And we say section binary section to let's just call it, yeah, binary translate section to section. Binary section to section enum. The thing is, we don't know, like now we know what is in this specific binary, but to have it work for all sorts of binary, we need to make a mapping, because not every binary will have all these sections, right? So that's why we need to make a mapping. Yeah. So we do this, and then we say, let me see, Parse. Map sections binary. Yeah, map sections. Okay, and then we go here and we create a private load void map section binary. There we go, map section. And then we do Um, So we need this one here. Section. Map section. I would say we do for IT section, binary sections. Can we know the size? Can we know the size of this thing? What happens if we call size on this? Does that work? What is this returning? How can our IT sections have a size? What the hell? How can an iterator have a size? Huh? The iterator contains a container? What is that? Yo, this iterator is wild. Huh? The iterator owns the container? What the hell? Nah. What is this bullshit? It contains a container. It owns a container. Nah. That is wild. That is wild. That is wild. This is so stupid. This is so stupid. How do you know where the end is then? How do you know where the end of the iterator is? Could it be that we have to say while IT section is not IT section.end? No way. Yeah, this is wild. This is wild. Plus IT section. So the iterator owns the container. It's so retarded. It's so retarded. Oh my god. Okay, what we can do now is, since we understood how this goddamn iterator works, this is wild. This is absolutely ridiculous. Okay, so we can say here resize to IT section.size, yeah. And why is this not working? Reserve, sorry. There we go. And then we can say IT section IT section n Parse and Parse section. Oh, what is this here? Type. Oh. Okay. Type. Segment. Relocations, content. Number. What is npos? Npos? It's not in here. Position. Index. Segment name. Well, let's do it differently then. We say size t, well, let's say uint 8 t index 0. Then we do here ++ index. Then we do to section. So index equals hold on. We need to say we need to say how about we make this a can we make it the const expr? Const expr char section names. Oh, that's nice formatting. I wonder if it should be, yeah, interesting formatting. Yeah, and then we say maybe we do a section size. section size. Okay, so let's do for U and AT. Section ID equals 0. Section ID smaller than section size. Section ID. And then we say if if IT section name dot equals section names section ID, then we do this. To section index equals section ID. Maybe we should also have the other way around. To section. Let me say from section. The other way. U and AT. Section enum to binary section. Maybe we need some better name. It's a bit confusing, isn't it? to binary section, and here we need a different word. To fixed section maybe, or internal section. Yeah, binary section to fixed section enum. Fixed section enum to binary section. Does that make sense? Yeah, maybe. Okay, then we do to fixed section to binary section, and then index, and we do to section to fixed section. Is that no? Index. We need to static cast section. Okay, and then to binary section, that's the other way around. Section ID. Section ID and by the way, is it really smart to use an unordered map? Should we use I think we should use an array actually. Yeah, we should use an array. Wait. You give it. Yeah, I think we can just use an array, no? Or am I wrong? So this basically so you index this with uint at, and so we say static cast size t, or I can simplify that too. Size t section size, and here to binary section this and this. I think that's all we need to do. Then we also don't need to reserve anything. Don't need to allocate anything. So, and then here we do index, right? So this is index, yeah, and this is section ID, yeah. And it maps to this index and this to that, yeah. And basically, if in our case, since we took these names in this order from this executable, they will basically map 0 to 0, 1 to 1, 2 to 2, and so on, right? There won't be any fancy mapping. But there will be... but there will be invalid mapping. Yeah, we should probably have a constructor, MachOCodeGen. We should probably fill these. Std fill n. Dot begin. No, fill n. What does it take? Destination. Begin. Count. Oh my gosh. Yeah, it's just pass this section size and value. We pass let's say unknown section. Okay, that's equal 0xff. Okay, you. Okay, and then we unknown section. Okay, and then we do the same here. Binary section size, unknown section. Yeah. Okay. Okay, and then here we can do this and this. I think that's already done. And then here we do a break. Yeah. Okay. And then we will map sections. Let's call this map fixed sections. Fixed sections. And then then we can let me think. I forgot. Section names. Let me see. We need a function. Yeah, function. Let's say we simply create one here or here. Uint at to fixed section, to binary section, to fixed section, and that will be to fixed section will return this, and then uint 8t section to binary section uint 8t no section, and then it simply needs to return m to fixed section and section. Okay, that is simple enough. And here it's return m to binary section. Yeah, that's simple enough. Good. Then we got that. Let's see if that works. And basically what this allows us to do is work directly with the sections without like reading the, like without comparing the names of those sections every time, right? So if we didn't have like a lookup array, then we would always have to compare the strings, like, okay, is this section, does this refer to this name or this name? But since we have this mapping here, then, oh, what is this? Const call twice? What? How is that possible? Const call. So it's once, okay. It's once in data and once in text. No. It's both. It's both in data. Huh. Okay. What does that mean? Huh. No, that's weird. There's two const calls. And they're both in data. text call, const call, const call. Okay, well, in that case, we would need to make it 1 and 2, I guess. Yeah. Okay, and then here we say const call. Okay, how do we deal with this duplicate now? Duplicate name. Sure. We can say if these section names match and to fix section and to fix section index no M2 hold on, I'm confused right now. So we go here through all the sections and then we go through all section IDs to check if we get a match. Section ID, how about section I think we need to check that this here, this one is unknown section. Maybe we should call it invalid section. Invalid section. I think this will work. Yeah, maybe. Let's test it. Yeah. Let's test it. Maybe we should also... Maybe we should also move this to the front because it's a cheaper check of the two. Yeah. Okay. Okay, we have also two consts. Const. Const. Data and data. Both data. Okay. So we do another const 1 and const 2. Const const core, const core. It's weird that they have duplicate names. Yeah. Yeah. Flags, original size. Name. Okay, good. Yeah, then let's see. So all these guys are set to, well, not all. Huh? What? Why is the first one 0? Huh? Huh? Could it be that we have to put data instead of begin? Huh? Why is the first one 0? What? What is this? What is going on? Why is it? Huh? Hey. Sometimes. Huh? Okay, everything is correctly set here. Why? I'm so confused. This. To me, it looks like maybe we already did something in this loop. Maybe this breakpoint is just poorly set. I don't know. It's weird. Okay. Looks like the breakpoint was just weirdly set and it already did one loop iteration. That's strange. Typically, if you put a... because this one is empty. Then it will put the breakpoint here at the first condition. Oh. I didn't know that before. Interesting. But it kind of makes sense. Yeah. Well, it's always best to put the breakpoint in the assembler, right? There you get the most control. Yeah. Okay, where are we? So, section ID 0, okay. So this should be pretty straightforward. Section name should match the first one here, right? And so this one, fixed section index, maps to this. And binary section maps to this, so they all map to one another. So we can put a breakpoint down here, and basically what should have been done now is, let's say, oh, what is what? What? It never finishes this loop? Why? Container. Huh? Oh, plus plus. Oh boy. Oh boy. So it never would advance an iteration and get stuck. Yeah. If the first condition would fail. This one. Interesting. So many bugs. My gosh. Good. That's why you always need to test your code because, or I always need to test my code because there will be errors. Okay, let's see. So basically it should be now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 16. Let's see if, yeah, this looks good. It looks good. Const 2, const col 2. Looks correct, yeah. This looks good. Let's see the other one. It should be the same. 0, 1, 2, 3, 4, 5, 7, 8, 9, blah, 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 blah. Yeah, okay. I mean, it's a pretty straightforward mapping here in our case. But yeah, okay, this looks good. This looks good. Good. Then we have that. And that should allow us then to use it here in the parse function here. What's the time? 1 hour 22. Okay. So now we should be able, so here we get the IT section number of section. So basically what we can do now we no longer need the binary, right? Because we have the section. So what we do now is we remove the binary again until we add it again. Yeah, eventually. Yeah. Yeah, binary. Yeah. Okay, now section. So then we do two fixed section const section. Let's go n section. Well, let's just do a number of sections and we just pass it here. There we go. Parse function, is that a static? Or what is going on here? No. Okay, section equals to fixed section. And then we don't need this garbage here. And then we can check what kind of sections we get and what we do with it. Let's put a breakpoint here. Yeah, let's put a breakpoint and see what kind of sections we hit there. And what we are interested in and what not. Yeah. Good. Okay, so const call 1 for, let's put a breakpoint down here so we see the demangled name. Yeah, overridable. This looks like a pretty good function to me. So we are probably interested in const call 1. let's say here number 5. Let's make a copy of this one and put it in here and remove the comments. And when we say const call, what is const call 1? Or I forgot. Yeah, const call 1, we say okay. Let's see. So that was the first. Let's see the next constructor symbol. Oof. That's a .eh. Okay. Let's say constructor eh. .eh. Okay, what else? Const call 1 again. Yeah. Type 1e. How about we clean up here our watch and we put in the name. We put in the section. And yeah, I think we just need these two. Okay, const call 1. Const call 1 so far looks okay. Constructor again, not okay. Const call 1, yeah, fine. Constructor, not fine. Const call 1. Constructor. Why is this in constructor when it is a destructor? I don't get that. Yeah. Okay, we get a lot of 5s and 8s now. Let's say section is not 5 and section is not 8. Yeah. Pick symbol stop. st show cursor. What the hell is that? What is a pick symbol stop? st show cursor. I don't know. Basically what I'm seeing are two different two constructors here for some reason. But this one says text. Pick symbol. Pick symbol. Pick symbol stop. There's no. Huh? Number of sections 1. Oh, what is this bullshit? Copy value. 1. So it must be one of these two there. Or this one. No, it's not this one. It's either this or this. One of these two. But it shows as text here. It's different. I don't get it. I don't get it. I don't know what to say. Here we have another one. Again. Twice. Pick symbol stop. And another one. This one as well. It's this one. 2632. 2632. 2632. Yeah, it's this one here. Pick symbol stop. Pick. Pick symbol stop section. What does the section pick symbol stop stand for? Oh, I don't want two responses. Just give me one. Pick symbol section is part of the indirect symbol tail and plays a crucial role. Dynamic linking. Stops trampolines that jump to dynamically linked functions. Why is it near external function? Runtime, dynamically. Pick symbol stop. Okay, so let's just jump in there. Pick symbol stop. Stops for position independent code. Well, then the question is, do we care about this or not? So this address here, if we search for this, then we also find this here. I don't understand why this is not in the text section. Here it is marked as text section. But here it says pick symbol stub. Why? Number of sections. That name is weird, number of sections. When I think of number of sections, I think of like how many sections this symbol belongs to, and not an index of a section. Right? So it's a weird naming. I wonder if I misinterpret this thing. It's certainly possible. Number of... It returns the number of sections in which this symbol can be found. The number of sections. The number of sections. It returns the number. It returns the number of sections in which the symbol can be found. It's so ambiguous. The way it's written is so ambiguous. Like really, like the way, like it could be understood two ways. Either it's like the section index that this symbol belongs to, or the amount of sections that this symbol can be found in. But it doesn't make sense. Like, why would a symbol have two sections? That doesn't make sense, right? But it's so ambiguous. The way it's written, it's poorly documented, I would say. But maybe that's just me. Type as defined. Type mask. Oh, look at that. Here are the types as well. Category. Local, external, undefined. Type, origin, category. I don't understand this pick symbol stub thing. If we look at the sections, Watch binary sections, section 1, stop, virtual address, oof, size 0. That can't be. That can't be. I think this makes no sense. I think we got something wrong here. Maybe maybe this number of sections is not an index. Yeah. Maybe it is something else. Yeah. Yeah. Maybe we need to do it differently. Maybe we need to binary. I think there's a function like get section by address or something, right? Get section. No. Section from offset. Here, section from virtual address. Yeah. I think we already used it somewhere else, so we should probably use that then. Okay, so that means everything we just did here for the sections is probably totally useless. Ah, boy. Oh, boy. And it also means we can re-add this one. Yeah. Which we had already so beautifully removed. Binary. Oh boy. Section from virtual address. Binary. Dot. Symbol. Dot value. And const section. Const section. Leave MachO section. Section. And I suspect that assert should be section is not null pointer. And then maybe work with that. Section, yeah. And this section will then. Now the question is, can we get some kind of maybe we can work with this type thingy here. A section type. section type, section type. Maybe we can do something with that. Let's see. Section text call NT. Does it have any number, any ID? So section type is core list, whatever that means. Core list, text call NT, frame, also core list. Yeah, we are not interested in that. Section type, section. There's no ID or anything here. That's weird. Too bad. Too bad. Well. Yeah. Looks like we need to work with the name after all then. Yeah. Seems like it. There's no, I don't see any ID for a section or index. It's just, well, we would have to manage it ourselves. Basically implement our own lookup. Not sure if that's worth it. Okay, maybe then we should just have a function that does do a string search every time. Maybe. Yeah. Okay, how about we continue here next session? It looks like quite a mess here, quite a minefield. We didn't get very far. Yeah. 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 But now I understand what's going on here with this stuff here. We have seen this. Yeah. So type is type mask. Type. and type. Pre-bound indirect. Whatever. I'll take a break here. Didn't make much progress, but okay, that's fine. Good. Have a great day or night. Until next time. Goodbye.